Hi, welcome back. And we are about to start looking at deforming our character mesh using the rig that we have so far. So before we do so, there's a few things that we need to do to our rig to have a nice deformation system for our character. And I'm going to talk about them in this video, and in the next one we're actually going to start working. So right now, yeah, you could think we're gonna bind our mesh onto these joints that we have over here, but that's not what we're gonna do. And the reason is the mesh we have on screen, these joints that you can see over here, is way too simple for us to be able to get good deformations out of it. So because of that, we're not gonna be using this rig to deform our character. We need to create an additional rig that is going to enable us to have better deformations for the mesh we have to deal with. And the reason is there are areas such as, for example, over here, the wrist of the character, where if you were to use this mesh that we have right now, you would have a lot of influence from this joint on all these vertices all the way to over here. And then here at the wrist, you have to transition between the influence from this joint to the influence from the hand joint. Okay, so there would be a lot of blending happening in a very small area, which results in something like so. If you would take the hand bone and rotate it this way, for example, you would end up with a lot of that rotation happening in the area of these vertices. And usually when you have a rotation that is big enough, you start to see this sort of like candy wrapper or towel effect happening here, and it's not very appealing. So what we're going to do is we're going to create systems for the arms and legs of our character that are going to enable us to distribute that rotation, the twisting, all along the length of the bone. So this results in a lot less tension in these areas and a more uniform deformation throughout the entire mesh. So we're going to create two separate additional rigs, deformation rigs for our character. One is going to take up that twisting along the joints, and another one we want to use it to do a little bit of volume preservation in areas that tend to get flattened out when rotated, such as the elbows, knees, and buttocks if necessary. So we're going to be looking at how to create those extra rigs that we're talking about, and then on top of that we will actually create the deformers, the joints that we're going to use to bind the mesh to. So it's two separate deformation rigs, if you want to think about it that way. One is a procedural deformation rig that is going to follow the movements of our main rig, which is this one, which is blending between the IK and FK systems all over our character. And the second deformation rig is going to be the actual deformers we're going to bind to. So let's get started in creating those two rigs, and then we can start deforming our mesh. Okay, so we're ready to get started on the twist system for our deformation rig. So let me hide the geo for a moment. I'm going to explain to you what we're going to do. So we're going to start with the shins of the character, his calf bone here. And what we're going to do is create a system that allows us to rotate a different amount of degrees at the base of the leg than you will have at the knee. So you're going to have a gradual fall off. And the idea is that as you grab the foot joint, I'm going to grab the FK because that's what the main rig is following right now. Let's set this to world. As you twist it this way, or in any direction for that matter, but let's take this way, you would see some joints that we're going to create rotate following this foot rotation at the base of the leg, and then gradually not rotate as much as we go up the shin bone. And then of course the last joints on this hierarchy would almost not rotate at all. So that way you can distribute the deformations in this area of the mesh at this location, well, actually throughout the entire calf, to have more of a gradual rotation instead of concentrating all the deformation on the ankle area. So that's what we're going to do. And the first thing is I just noticed that my FK controls have some residual transforms over here. And this is very likely a result of all the reparenting that we've been doing to create this modular rig system that we have right now. So since we have this, if we explore the hierarchy, you can see that we have these values all over the place. What I'm going to do is just double click here and zero everything. I'm going to do the same for the other leg and do the same for the arms. Do we have something in there? 0, 0. These guys are zeroed out. If you see, it said here it's mixed. I'm probably selecting as part of this hierarchy stuff that I can't see right there. Well, not really. It looks like I only have these two. So it's funny that we're getting mixed values over there. But anyway, those are zeroed. So this guy is not. Let's make sure that we don't have anything funky in our channels. This guy seems to be okay. Our friend here is not, so let's zero him out. How about the clavicles? I'm actually going to do this offline later on. Just verify that all my controls are zeroed out. You should probably do the same on your rigs. Once you do a lot of heavy reparenting and moving things around, you want to make sure that you don't have any values on the controls that the animator is supposed to touch that are not zeroed. Okay, so let's get started with our leg system. I'm going to close the arm group over there, and we're going to work on the left side of the character. So we're going to use a system that traditionally in other applications is based on IK chains using 2 joints, but because Modo's IK system cannot work with 2 joints only, at least the dual 2D IK, which is the fastest to use, I'm going to use basically a direction constraint, because actually a 2-joint IK chain is just a direction constraint. So let's do that. I'm going to create my first joint. Well, in this case I'm going to use locators, because joints are nothing more than locators in a hierarchy with special display properties. I'm going to set my drop action to match, and I'm going to drag and drop it over here. Okay, so we have one locator over there. I'm going to create a second one, and I'm going to drag and drop it over to the foot location. Okay, and what I'm going to do is I'm going to take this second locator and make it a child of the first one. So now what I'm going to do is to have the same orientation in both. I'm going to take this locator and reset its rotation. So now they are both oriented exactly the same way, okay, which is what I want. However, this hierarchy that I'm creating is going to be going in the opposite direction of the leg, because I want it to be based on the rotation of the foot, okay? So I need to follow the rotation of the foot closely, so I want the hierarchy to start at the bottom, okay? And in this case, I don't actually need this to be a hierarchy anymore. So I'm going to take my second locator. I'm first going to rename it. Let's call this guy locator left shin twist start. Okay, and I'm going to take the second locator, which is the one on top, which is the parent right now, and call it lock L shin twist target. You're going to see why this is a target in a second. I'm going to take the first locator, and compensation is on. Let's unparent in place. So now they're both totally independent objects. And I'm going to take both of them and I'm going to parent them over to our shin bone, the calf joint that we have created. So let's do parent in place. Let's go find them. There they are. There's our calf joint, there's our foot hierarchy, and then we have our two new locators. Okay, so I'm gonna take this guy and change its display shape. Let's make him into a nice sphere, which for the time being I'm gonna leave at slightly large size, like so. And this friend over here, I'm actually going to turn him into a box. Okay, let's also make him smaller. Something like that. Now, what I need to do is to create some intermediate objects that I'm going to use to create the twist bones that or twist joints that we're going to use in this hierarchy. Okay, and I'm going to base them off of this twist start joint. So let's get 1, 2, 3 of those. You can actually create as many as you need. I'm just going to show you how this mechanism works, and then you can adjust this to the needs of your own rigs. But for this character, we're just going to throw 3 more of those. So let's duplicate 3 times. There you go. And we're going to call this one, instead of start segment 1, this guy is going to be segment 2. And this guy is going to be segment 3. Now I want them to be spaced evenly along the shin bone. So to figure out how much they need to move, I'm going to take the 3 of them, and I'm going to parent them. Actually, I'm going to take 3 and parent it to 2, 2 parent it to 1, 1 parent it to the start, and I'm going to take the target and also parent it to the start, and you're going to see why in a second. So if I take my target joint here and we check out its properties, you will see that there's this distance along the x-axis. Okay, there should be no distance at on y, and none on z. There's like a super tiny difference there. Okay, and I'm gonna take this value, copy it, and I'm going to go to our first segment here, and because I'm using 3 of these that I want to space evenly, I'm going to paste that value as the x position divided by 4. So he's going to move up a little. I'm going to go to the second one and do the same. This value divided by 4, and go to the third one and do the same. So now we have our evenly spaced joints right here. And now I'm going to put them back as a child of the shin bone. So let's select him, and the target. Shift select the shin bone and say parent in place. Now we go back to a flat hierarchy. Okay, so now what I'm going to do is I'm going to take my start joint over here, and I'm going to direction constrain him towards my target, which is over there. Okay, so let's go to modifiers, and in this case I'm going to turn off compensation and do a direction constraint. And on the direction constraint, make sure that I'm using the x-axis as my constraint direction, and we're gonna set the up vector to be it's not working with Z. Let's try with X. There we go. Now our joint is back to its previous orientation. You just gotta keep an eye on its local axis down here. So now that it's properly constrained, as you can see, he's still properly aligned and everything. Now, we're going to give him an up vector, and that up vector is the one that is going to rotate him depending on the rotation of the foot. So let's create another locator, and I'm going to drag and drop it to match our joint. And since things are getting a little bit difficult to understand, I'm going to take all these guys and I'm going to change their display properties. So let's give them some other colors. So let's go for something kind of like a bright orange for our locators right there, so we can recognize them. So now we're going to take our new locator and match it over to the first one over here. And I'm going to move it back, but I need to do that in local space so I don't disturb its orientation relative to this guy, because we need them to be on the same plane, because he's going to be an up vector for our friend here. Okay, let's just make him, well, smaller. Let's say something like that. Okay. So now we're going to take our friend here. Let's make sure that the direction constraint is selected, and we're going to shift select our locator we just created, and we're going to say assign up vector. Okay. So now when I take this guy and move it around, you can see the root of our chain rotate. Okay, that's great. Now what I'm going to do with him is I'm going to parent it to the foot joint. Okay, so let's go to setup, compensation, parent in place. Okay, so now he's a child of the foot joint. Let's rename this locator. It's going to be up vector left shin twist. Okay, so now see what happens. I'm going to take the foot FK joint, because right now the entire rig is following the FK control system. Let's go to world rotations, and I'm going to rotate my foot like so. And you can see that our first base joint right there is already following our foot. Okay, I can even rotate this guy, and our aim constraint is working fine. So what we need to do now is to get these guys to twist based on the orientation of our friend here. Okay, so what I'm going to do is we need to select a few objects that we are going to rotate constraint. Okay, so we're going to select the item to constrain, which is our first joint over here, and he's going to have two rotation targets. One is going to be the shin bone or calf bone, and the other one is going to be our twist start. Okay, so we can turn off compensation and we can say rotation, and it looks like he jumped there somewhat. Let's undo that and check why that is. I'm gonna go here. Oh, that's the reason. We have here some rotation values and transforms, so we should not be seeing any of those. And also let's zero out our rotations. We're gonna make sure that that's the case for all the others. There we go. So I'm gonna try that again. Let's make sure our local axes are the same. Okay, this guy X up, Z backwards, Y forward. That's why. Our friend here is using Y as an up vector. So let's check what's going on with our joint. We're going to have to give an offset on the x-axis of minus 90 to rotate him back into the proper orientation. So now he has z pointing backwards, y pointing to the right. Okay, so now that should work. That's why these guys rotated out of place. Let's try that again. I'm going to select my first joint over here. I'm just going to get rid of the constraint selection there, just in case. Shift select the shin, shift select the start, and let's do that again. Rotation. I think he moved a little bit, but nothing we should be concerned about. So let's see what happens now. As I rotate the foot, we can see the shin is starting to rotate, although it doesn't rotate as much as the foot is rotating. And that's because since we assigned 2 targets for the constraint, this guy is weighted right now 50-50. So he's trying to keep a 50% orientation towards the original shin bone and a 50% towards the foot. And we can tweak that a little bit later on, so I'm going to show you how. So let's do the others. For these guys, what I'm going to do is, instead of constraining them to the same targets, to the shin bone and the foot, and then changing the weights on each one of these guys, since I already know that I want to rotate a little bit more towards the foot and then a little bit more towards the foot too, my constraint targets are going to be our friend that we just constrained and our root. So that way he's going to rotate in between this guy and the foot, which is a little bit more, and then he's going to rotate in between this guy and the foot, which is even more. So that's how we're going to get our fall off sort of going on in there. So let's go ahead and select him. Then the joint which is constrained and the start, and do the same rotation. And then we're going to take the last one and then shift select the previous one and then the start, rotation. Okay, so if I take my foot control right now and I rotate this way, you can see there a gradual rotation of these guys trying to follow the foot. Okay, so that's what we're after. So that's our twist hierarchy for our shin on the inside of the character. And obviously we just need to do exactly the same thing for the other side of the character, and we're going to have our twist system already done for the lower legs for this character, and then we just have to do the thigh part. I'm just going to pause the video right here and I'm going to do the other side of the character, and then I'm going to come back when all this is done to show you both systems. See you in a second. Okay, I'm done. I've done the other side of the character, as you can see right here. There were a few things that you need to be aware of, or just remind yourself when you're working on the opposite side of the character. First, the axes for the constraints are flipped, so this means that this guy is constrained on the x-axis, but using the negative direction. And also the offset is going in the opposite direction. It's positive instead of negative. Other than that, everything is okay. And also there's one thing that you need to be a little bit careful about, and it's that this system, because of how these constraints work, reaching a certain point does flip, which is 180 degrees. You will see that our friend down here is flipping. But I mean, I'm not thinking for the purposes of this character we're going to be rotating his foot that far, so no need to be concerned about that. And the other thing I like to do is I tend to find the rotation starting at 50% up here a little bit too drastic. So I want this guy to pretty much almost stay in place and not rotate as much. So I'm going to do this for both objects over here. I'm going to find their rotation constraint, and let's go to the channel list, and you will see down here the weights for the targets of the constraint. So we have our calf bone and our shin twist start locator, and they're both at 100%, and that obviously if you add them both, that makes you 200%, but Modo just takes this as a normalized value and it's 100%, which means in reality it's 50-50 for each. And what I want to do is change those weights. I'm going to set the first one to 80 and the last one to 20%. So what will happen now is, as I rotate this guy down here, you will see most of the rotations happening at the bottom of the foot, and not as much happening up here. Okay, and it's still a progressive rotation where each joint rotates a little bit less and less than the other one. So let's see what we have for our next joint, which is the segment 2. If we select those channels, he is weighted between segment 3 and start, segment 3 being the one up here. So we could also change the weights on these guys if we wanted, but if I go back to the one I just changed, and I changed these values, let's say that I increase the start to 60, you would see these guys automatically adjust because they are weighted depending on this guy's weight. So we can actually just take care of this, and that's what we're going to do when we start creating the UI for the character. And actually we can prepare it right now, is create a bias system that will allow the animator to, if we wish so, or we can just leave it hidden for the rigger to take care of that, to weight these deformations a little bit. So if I want to do that right now very quickly, let's go up and go to the legs rig workspace, and let's bring in this joint over here. As you can see, it came in already wired to something down here, which is a calf. Yeah, here's our constraint. So what we're going to do is take these weights and drive them through a math node. So let's do math add, which we know we use as our placeholder, and let's add a math subtract, okay, that we're going to use to do a 1 minus operation. Okay, so 1 minus this to get the inverse value. Let's rename him to UTIR calf twist bias. Okay, so the way we want it is, let's see what the weights were on the constraint. We want the original value to be the calf rotation and the 1 minus to be the shin rotation. Well, yeah, so let's do 0.8 for this guy. The other guy gets 0.2. We're gonna wire this guy here, and we're gonna wire this guy there, and we're done. As you can see, now we can use this value to rebias the rotations on the entire spine. So we can go less to get more rotation at the top, or all the way over to 1 to get no rotation at all at the top of the leg, and everything is happening in between. So depending on the topology of your character and the type of character you're dealing with, you might want to adjust this value differently. For now, I'm going to leave it to 0.8. When we get to actually skinning our mesh for the character, we're going to obviously revise this. But for now, that's it. I'm just going to do the same for the other leg. Let's just reset the rotations on this foot. So let's take him and add him to the schematic. And he is now on the other leg. So let's bring that over here. I'm going to do exactly the same. We're going to add a couple of math nodes, and add, and I subtract. We're going to set this guy to 1 minus, and this guy twist bias. 1 minus this guy's going to be 0.8, and we're going to do the same thing. Wire this guy here, wire this guy there, and we're done. We now have a weighting system for the deformations on the shin of the character. We can very quickly test everything again, and yeah, working good. So the next step would be to obviously do the thighs of the character. So let's take care of that in the next video.